Thanks everyone for joining. We are recording this. It'll be posted to YouTube. Um, and right now, everyone is muted, but if you have questions, you have something to interject, it's fine to unmute yourself. My style is it's fine while I'm presenting to go ahead and interject questions instead of waiting till the very end. Let's go ahead and address topics as they come up. In some cases, I'll let you know, hey, that's coming up in 1 or 2 slides and we can discuss it then. Otherwise, we can address your questions or hear your inputs um, on the fly there. And let me just add that I think with our audience today, it's really important for us to hear your perspectives on this because I am not a licensed installer. I've worked with a licensed installer on projects. I've inspected a lot of arrays, but there are nuances that you're more familiar with. And I'll throw one out there right away. That's a question I have, and that will be, are there issues in which when you need spare parts, replacement parts from say a inverter manufacturer, that you have to be the original installer? Whose name is it? Under the customer's name? Is it under the installer's name? How do you work those things if you're coming in to try to repair a system that maybe you did not personally install? So anyway, I'm looking forward to your inputs, and we'll go ahead and get started. So the lead slide here, here's our cover, and some of you might recognize this as a SolarEdge inverter screen, and this is a site that I encountered where it was in a fault state and module communication. So the reason why I wanted to cover PV operations is that we are getting to the end of the tax credits. They're sunsetting the residential tax credit at the end of the year, and then investment and production tax credits are going to be sunsetting a little bit later, but there's still deadlines to get systems built to a certain level. And that means that it's even more important than ever. And oh, yeah, so it'll only be slightly bigger within presentation mode. There's some notes in here that I want everybody to be able to see at the bottom. So let's see if I can go just a little bit, just slightly bigger. But now that we're losing these tax credits, I think it's even more important for us to try to get the best performance out of our installed base. And although it should have always been a priority because people pay for these systems and they want to get the most energy that they expect, that we modeled and told them to expect on these systems. So here we go. Our agenda is going to be, first, I'll just give you the kind of the standard how to join ACES if you're not already. We can do some introductions to understand who's here participating. And then I'll show you just some examples of residential, commercial, and utility scenarios that I've encountered. And then we're going to really start talking about hearing from you and just going around and understanding what kind of regular monitoring that you recommend for finding issues with arrays, any common issues experienced in the field. What are array owners' attitudes around O&M? Were they expecting to need to budget anything for that in the future? What level of priority is it for them? And then the real stickler that I see, but you may have others, is providing O&M services when you're not the original EPC or installer. And of course, we can cover other things too, as you think they're important. So joining ACES is real easy. There, you can go just to the ACES site and you can find membership. These days, the most basic membership, if you want via mail, is $50 a year. Auto renewal makes that $40. Or if you want the online only or digital only, that's $34 a year. With auto renewal, it's $24 a year. So really screaming deal. And of course, there's higher levels of professional membership and even lifetime membership if you want. But if you're not already an ACES member, it doesn't cost a lot of money. So that's that part. Let's go ahead and just do a quick introduction. You can come off mute and I'll just call you out as I'm seeing you across the screen and let us know where you are. Are you an installer? What other role do you have? So my role, Rich Stromberg, I'm based in Southern Colorado. I'm a solar researcher and a PhD student. John Steele.
Hi, Rich. Yeah, I'm sitting in Denver. I'm a mostly retired professor from School of Mines. I've installed my own system on my house. I'm designing one for the standalone up by my cabin. Been involved with solar since the 70s.
Great. Paul Farron.
Yeah, can you hear me?
Yes.
My camera mic is bad, so I had to wear the headset. I wasn't sure that it was active. Okay. My name is Paul Farron with the Energy Store in Hollywood, Florida. I'm predominantly a designer, although I do monitor sites daily in Outback, Schneider, Solar Edge, and Generac. And I do on-site maintenance, like I just changed out a BMU, but I don't use regularly. I'm not regularly a technician and an installer. I hire them to do that.
Awesome. Thanks. Wilden.
I'm president and founder of the New York Solar Energy Society, and we've worked so hard in the area of photovoltaics. And I think the adoption and the message that ASUS wants to put forward to the public has to be very, very carefully crafted with facts. And thanks to the team like Rich Stromberg for hosting these kinds of webinars.
David. David, we can't hear you for some reason, even though you're unmuted.
Okay, how about now?
Yep, good.
Yep. Okay. Yeah, I work for a company called company called Rudolph Libby Group here in Ohio. We're involved in installing some medium-sized ground-based systems here in the Midwest and the Mid-Atlantic. We're primarily an EPC. I myself have been involved in solar, for quite some time. I'm mostly retired now, but I'm working part-time helping with the systems. I'm an engineer, and I'm mostly here to learn.
Thank you. Drew.
Yeah, I'm a retired professional engineer from MIT. I have 2 net positive homes, one in Florida and one in New Hampshire. They're both about 10 years old now. Recently added batteries. The net positive includes all of their energy use, and I can even have another car for each of them. Both systems are microinverters. It solves the monitoring problem. You know what's going on all the time by panel, which has proven to be quite useful with the earlier system, which has had about 50% of the 43 microinverters from Enphase fail over the years. They've all been replaced under warranty. And currently, I think I have 1 solar panel itself, which is not putting out the full amount. But who cares when you've got 43 and you're net positive anyway, and the utility's only paying you 2 cents for your excess electricity. So anyway, that's the background. And also, it amazes me that I can spend the time to monitor my systems and my relatives' systems to let them know when things are not working. But people with multi-megawatt systems don't even install monitoring. It baffles me. Unless you put it in, it should work, right?
Right. Yep. Good point. And I'll just add to that. I see that a lot on central inverter systems with just DC combiners, and they'll have one monitoring location of what's the DC voltage and current coming in, what's the AC watts going out, and that's it. Nick, you're next.
Yeah, hi, my name's Nick Kirk. I Yeah, I've been in the solar field for 15 years, running my own company at times. I worked for Mayfield Renewables as an engineer for several years. Currently, just installing solar in my little town in central Colorado. And for the first time ever, I installed solar on my house this year, so that was pretty exciting. So after
Great.
doing it for everyone else for 15 years, I finally got it for myself.
Yeah, it's the cobbler's kids have no shoes, right? Is that the
Yeah.
saying? Yeah. Tarek.
Good afternoon, everyone. Can you hear me?
Yes.
Perfect. I work for a CNI developer on their asset management team, supporting the monitoring and performance and reporting for commercial PV and battery storage systems. And I'm also a part-time student at the School of Mines.
Thank you. Near.
Hey, can you hear me?
Yes.
Okay, great. Because near Kakor, I'm an engineering professor in New York. Let's see, I'm an ACES Life member. I'm helping to organize the conference this coming year. What else? Yes, I'm just interested in learning more and sharing with my students some of it.
Thank you. Great. Lewis. All right, Lewis might not be able to come off mute. Let's go with Daniel.
Yeah, Daniel Simon from Chicago. Basically just listening to learn at this point.
Thank you. Bernard.
Hi, I'm in Terrytown, New York, just north of New York City. Longtime electrical engineer. Longtime ACES guy, 84 graduate from Trinity University. I'm underneath the solar canopy here in Groton on Hudson right now at the train station, walking home. I work at Regeneron right now, and we're doing a huge campus expansion. We're putting solar systems on since I've been there the last 5 years. We put 2 systems on, and in the middle of building a third one out now with another canopy system to go. And I work with a lot of the facility ops guys who do the maintenance after we build the systems. We turn them over to them. So I'm interested in knowing, the pricing that's going on with the maintenance and what the different people do in the contracts, whether you're doing a daily monitoring, quarterly, those type of things.
Yep. Good points. What's it cost to roll a truck for a residential system versus a community solar garden versus a large, even larger multi-megawatt array?
Yeah, and I got a solar system on my house now. I don't know, 10 years. We just augmented it and put some batteries in 2 years ago.
Awesome. Great. Daniel. Daniel might not be able to come off mute here. How about Nicole? We'll wrap it up with Nicole.
Hello, Nicole here with Solar Oregon, and just here to learn more of the technical piece. I do a lot of educational programming and can answer some really basic questions, but I want to just dive in and excited to be here. Thank you.
Thanks. And for Lewis and Daniel, you can also just introduce yourself in chat too and let us know where you're at and kind of your basic background. All right, so let's jump into things. I think we all would like PV systems to be set it and forget it. And I look at a lot of arrays and a lot of them are in great shape. Although the bigger ones, yes, you start having individual modules with issues or a fuse that's blown on a DC combiner, but the vast majority of them are running pretty well by themselves, but most can still run at least a little bit better with some periodic attention. So I wanted to show a few examples. This one actually happened on Monday. One of the things that I do is I run a solar reuse nonprofit, and that reuse of PV systems is the focus of my PhD research. And so there was an array owner in on the north side of Pueblo, Colorado. He's a Vietnam vet, and I had looked at his system about a year ago, and one of his evergreen solar 190 watt modules had gotten broken when a trash can blew in the high winds over towards one of his 3 pole mounted ground mount arrays. And so I'd been keeping an eye out for replacement, and last week happened to pick up a 195 watt evergreen solar. And so I called him up and said, hey, Juan, I've got a replacement module, and can I come out? Did you ever find one? I can come give you one of these. And he said, yeah, but I also have to tell you that my array's been down for about 6 months. And he's tried to get somebody to come out and look at it because the original installer is no longer in business, hasn't had any luck. And so it's like, okay, I'll come out and do what I can with a couple caveats. One, I may just be able to find an issue, and we'll still need to find a solar installer who can fix it. And second, because I'm not a NAVCEP licensed installer, I have a lot of experience, but I'm not licensed with the state. You cannot pay me. Although I said, if your wife wants to give me some more homemade tortillas, we're good on that. So anyway, he sent me this photo on the left, and it says error 1302. And that morning I pulled that up and it said, oh, AC grid connect issues. This might be easy. And sure enough, what we found is one of the AC fuses between the inverter output and on the outside, there was a disconnect, AC disconnect going to his service panel. And we opened that up, opened up the circuit and measured, and it was just one of the 2 30-amp fuses was blown. And so I drive over to the electric supply store, get a replacement fuse. And as you can see, we're back running again. But so here's an example of, we had a $9 fuse. The value of the lost generation though was $611 for the 6 months that it was down. So it would have been nice if he could have gotten it repaired sooner. And this is literally something that I think he caught it on his next monthly bill when he saw his production going down. So he's looking at it that way. Another residential issue, this is up in Nederland, Colorado, and they had multiple Sunny Boy inverters. One was offline, and then practically the worst soiling I've ever seen. I don't know what the source is of all this heavy soiling in that community, but so they're losing the amount of a full inverter output. And then I haven't quantified, but they are losing quite a bit on soiling on this system. Here's a commercial system in just outside of Boulder, a community, and it's a rooftop 100 kilowatts. And when I walked up on the rooftop, 2 of these arrays were running and producing power, and I could look at their logs. 2 of them were in an error state, but I could still go through their logs and see when they went offline. One had been offline for 1.5 years, another for 2.5 years. And then the other 2, I couldn't even get access to error codes or anything. So it's unknown how long they've been offline, but I would assume about 2 years as well. And one of the problems is, as you get to a company, an organization this size, this is like a regional housing authority. They own different affordable housing and senior housing buildings. And what happens is there's no one in that organization whose job it is to check and monitor these on a regular basis. So if no one else is doing that, it can be a long time before an issue is found. And what happens in these large organizations is accounts payable gets the monthly electric bill, and they don't know that they should be checking to see what the production is on that system to notice, oh, there's been a 1/6 or 2/3 drop on our power generation. But they just look and say, oh, the electric company says we owe this much, we pay them that much, and the next month same thing happens. So there's really no mechanism for them to check that. So when I found it, the original installer was no longer in business, and it was still almost like pulling teeth to get another installer to come in and troubleshoot the system and get it repaired, even though in the Boulder, Denver area, there are a lot of installers there. So that was a challenge for them. Lost revenue per year on this system for what's down, 14,387, and multiply that by at least 2. And then here, I'll go ahead. I will switch now to this mode. So here's another system owned by that same organization, and they had a single 100 kilowatt central inverter on the ground outside the building, on kind of the backside of the building. So before I go up on the roof, I just walk up to check on the inverter, and I can see that it's in a fault state. We have DC volts, but there's no amps. And then on the AC side, you can see where it's connected. It's 208 3-phase, and but no amps going out. And there, we got some fault codes. So the first thing I do is like, well, let's just do the old Apple computer early days, power it off, power it back on. That fixed it. So this system had been off 4 months, probably at minimum of 4 months, but it's the same issue of there's no one checking on the system. And I don't think that there is a remote monitoring portal for this array for anyone to even look online, whereas the SolarEdge array there is. So we had those issues. All right, here's more utility scale, small utility scale of 1 megawatt and larger. And this is an array that had been built, but the owner is clearly not doing full maintenance because we have vegetation issues growing up. This is built on top of a retired landfill, so it's ballasted mounts and they're flatter on
So
their
that's a
tilt.
green system.
Yeah. Yeah, exactly. Another thing besides the vegetation management is no one had been doing the periodic torque checks on the cable terminations. And you can see there's actually multiple arcing spots. And we found several of the DC combiners here that were had issues. And I'm going to go back to, see, this system we lost at least $7 grand in generation value. Here, this one, annual revenue loss was at least 26,000. There's one of the 2 central inverters was down, vegetation management, cable termination issues on multiple DC combiners. So clearly, in fact, I have to wonder why the system owner, since was not really on top of this, trying to get it repaired so they can increase their revenue. Some of these things I don't understand the motivation or lack thereof. Here is a community solar garden, 2.5 megawatts in Colorado. And you can see we have an issue of trackers. Like here's some modules. It's almost like torqued on the tracker row. And some of these over here and over here, whereas others are just flat. And here's another view. You can see one of the drive shafts has broken off and is just laying on the ground. Some of you may recognize this tracker manufacturer. When first I thought, hey, let's try to get access to also tilt the trackers so that we can start assessing the modules. But when I looked into it, I found out that this tracker manufacturer is fairly notorious for having issues, and the different gearboxes were binding up. And so it literally over torque the motors would trying to turn it, but it would be seized up. And so you actually have some twisting of modules. And if you try to run it, once it's doing this, you can just cause more damage. But as a result, the modules, the O&M provider has chosen to just park it in horizontal to minimize the further damage. The problem is that on this system, if I come down here, it's parking it with zero tilt. They're losing $135,000 a year by not being able to track, plus the soiling issues that we do see on these modules because they're just staying flat. And when it rains, get a little bit of dust, you get that soiling collecting on some of the corners. So this is a big issue, and really, in my opinion, the company that built this and the O&M provider, they need to be addressing the issue directly with the tracker manufacturer, up to and including if they can't get their issues fixed, there needs to be some sort of compensation through the courts, because this is just not acceptable. And this is a solar garden, so the subscribers are missing out on what, $120,000, $130,000 a year of shared benefit to offset their electric bill that they invested in, and they're not getting that. So, that's a major problem. So those are some examples just to kind of stimulate some thoughts, some discussion. I'm sure you've seen plenty of other issues. Again, a lot of the stuff we work with is in great shape. I'm focusing on the problem ones. But so now we're really going to open it up and just hear from you. But I'll leave this slide here for just kind of some questions of what do you topics to cover, like what do you recommend for monitoring frequency and detection of issues, any common other issues that you experience in the field. Let's talk about array owners. Are they hesitant to spend any money on O&M, how it's a priority? And again, the question I raised, if you're not the original installer, what challenges do you have to provide support for a system that's not working? So we'll open up the floor.
Okay, I can comment. With SolarEdge, it used to be where you just have to submit a form to them to change vendors, change providers. However, about 6 months ago, they're now it costs you $150 to change. Also, you had mentioned about those solar edges that were down. If you're not monitoring on a solar edge, that you're not covered under warranty. And so, as I say, I don't have a lot of systems. I've been doing this for 20 years, and I built off grid and on grid and custom beach huts for like 100. I probably have 100 hotels with my solar panels and battery systems, so they can swipe credit cards and stuff. But I do a lot of Solar Edge. I do Schneider and Generac also, but I monitor everything I do. I do monitoring, and I do have some Enphase systems too, where I need to monitor each individual panel. And but Solar Edge is very, very difficult to deal with, to get through and have someone that can communicate in plain English to for support. But
What do you
and they
mean
have
by, it costs you $150 to change what? To change who's monitoring them?
change the vet to change your change the monitoring. Who owns the monitoring system?
Right.
The technician. You have to. It costs $150, and you fill out the form and everything, but you also have to pay $150 to do that.
Yeah, it seems that when we built these last couple systems on our site, and you guys, do you use also at all?
Yeah, Also Energy's based in Colorado. I've used them some.
No,
Yes,
I just use the manufacturers.
Yeah, so the company that built the system for us decided they're no longer doing commercial, industrial, but just utility. So they kind of abandoned us, but they still are the ones who are controlling our access to the monitoring. Is that typical?
I had to work on that with literally putting in a request and getting the system owner of record to approve me to get access to view that system. It was a little cumbersome, but when I actually was able to contact the person within Also Energy to get that access, it went pretty quickly.
Yeah. Yeah. The other thing that we're running into is that there's so much dynamic change going on in the industry right now with the contractors who are doing our systems, that it's hard by the time we conceive and go out and get an RFP, we start contracting with the guys. By the time the system is built, they may have pivoted and now they're changing their business model. and kind of abandoning us. And so then we're going to other people to, as you mentioned, to go ahead and maintain systems that they did not build. And that's our typical situation.
I'd interject here that I can't speak highly enough of Enphase and their customer support throughout the 10 years that I've had their systems. It's absolutely amazing. You get through to a person who's knowledgeable, who talks you through anything you need to do, and usually they stick with the problem until it's solved. It's absolutely amazing to eliminate all these middle people that string inverters seem to use. And we end up, one company, one customer service, and it's really, really good compared to most stuff out there.
Is
I
that on the
assume that
residential
other
side?
microinverter manufacturers are doing the same kind of thing. Yes, that's on
Yeah.
the residential side.
Yeah,
But it
that's
would
the
be no
system
different
I
on the
have,
commercial side.
even if they didn't have microinverters on them.
I don't understand the
You know,
question.
like
Enphase
if,
makes
like,
microinverters.
what I'm saying is that on a typical, the rooftops, when we're not using the microinverters, are you suggesting that even on those situations, we would go ahead and use the
Yes,
microinverters?
absolutely. It's another case of people are looking at the original capital expense and saving maybe a dime a watt on the inverters by using a string inverter instead of a microinverter, which actually gets to be less than that when you count things like Solar Edge and their optimizers
Yes.
and the failure rates and all of that. Just put the stuff under the panel, make each panel communicate with the mothership, just like Tesla does with its cars. And then you eliminate all of this stuff and you end up being able to monitor each panel, its output, each inverter, its output forever for free. It's wonderful.
One of the systems we have, we're using those optimizers on the Solar Edge. We've had, the system's been up for a year. We've had an inverter go bad that they've replaced. And then I guess maybe that was just a communication card for it. But aren't the optimizers doing, from a monitoring point of view, I think we have a pair of panels on each optimizer.
Right,
Don't they
they're
kind
right
of do the
there.
same
That
purpose?
alone, it's such a nonsense. They market it as panel monitoring. Really, it's 2 panels at a time monitoring. It's a lie. Whereas with Enphase, it's 1 panel, 1 inverter. With some of the other microinverter folks, it's 4 panels on 1 inverter, but they each have their own channel that's monitored. So
Like
you get
on
complete information.
like on Generac, there's 6 to 8 panels per PV link, they're called, and so you just monitor those. On regular string inverters, I kind of agree with this gentleman that it's good to just watch every panel, and we use Tyco optimizers on when we're using string inverters, and they're not, the proprietary factory doesn't have optimizers.
I'm kind of curious on the cost and failure rate for the optimizers. It strikes me that the way those are set up, they're basically designed to turn things off. And they cost more, and they're an added installation nightmare. And I just can't imagine how it makes any sense compared to let's put all the electronics and get it into AC right there with the panel.
Well, there's an argument back and forth where if you use DC optimizers, you're using much higher voltage, less wire, smaller wire, and the fact is that optimizers used to fail a lot. Now they've evolved to the point where, like, I have a system with 64 optimizers. It's been out for 3 years, and 2 of them have failed in 3 years. But they're very easy to replace. You just take them out and put them back in.
A truck roll's a truck roll. It's $500 to do anything.
Right.
Back to Bernard on some of your systems. It sounds like what size systems are you working with? And for some of the larger arrays, are you using string inverters or central inverters?
So we did a 995 kW canopy system. We have 14, I think they're 50 kW inverters. That one we're monitoring with also. And then we have a smaller system we just put in with a local guy in Croton, 140 kW with Solar Edge and the optimizers. And now we're doing another rooftop system, 550 with Q-cell panels in all these. And we're doing Solar Edge, and we have like 5 roofs on this building, and we're doing 5 sets of Solar Edge inverters, you think, on them.
Okay. One thing on the string inverters now is when you're looking at larger systems, you can get 50, 75, even 100 kilowatt plus size string inverters with multiple MPPT inputs. And in some of those cases, you get voltage and current for just the combined strings feeding that input, but others actually have the feature where you can see the voltage of each individual string coming in to multiple strings on an MPPT. And through your remote monitoring on their web portal, you can still see a drop in voltage on a string, even if it's, say, a third of a module. So let's say that's like 13, 15 volts different. That alone will tell you, hey, I've got something on this string. I should go off and look and do some troubleshooting. So I like some of the newer string inverters that you, on these larger systems, you get some nice data monitoring. And I don't know if Nick can talk to that a little bit on the revamping, the revamping you did for the Leadville array, but you ended up putting in string inverters to replace a central inverter.
Yeah, thanks, Rich. Yeah, that's a project. Was just happened to be in Leadville when the local environmental group purchased it for $1. It was going into bankruptcy. The company that owned it had, like, I don't know, dozens of these things across Colorado that were community solar arrays. And because of O&M costs that they hadn't accounted for, they ended up losing all the arrays or selling them off before bankruptcy. And our local environmental group, can you guys hear me okay?
Yep.
Bought 10 of these arrays in Colorado for $1 each. Screaming deal. Unfortunately, though, 2 of them had a failed Xantrex, now Schneider central inverter. Is a 500. These are smaller community solar arrays. They're like 500 kilowatts. And the one in Leadville had this issue with the central inverter, and they went to the 3 largest shareholders and got funding to replace that inverter. The inverter is actually under warranty when it failed, but the company Schneider wouldn't honor the warranty, and they were going to charge them like $300,000 to repair or replace this thing. And so they went to the community. I happened to be in town, put a local team together. We did it for a fraction of that cost, and we put in we had to maintain the AC rating on the system for the interconnection agreement. So we put in 5 100K AC Solis inverters. And that was the first time I'd worked with Solis, and I'm really impressed because it's an older array, 10 years old, and the modules were wired to 600 volt strings for the central inverter. We could have kept them at 600 volts and plugged them in to these Solis inverters because their MPPT windows are something like 150 volts to like 900 volts or something. So very wide range. although we would have had to have more inverters because of the number of strings. And so instead of doing that, we went through and rewired the strings, which that's pretty labor intensive. But one of the primary reasons that the central inverter had failed was poor wire management. And by the time we came in to do our repower on this project, we were, it was the third time the system had their wire management updated because they were using the wrong products. Here in Leadville, we're at 10,000 feet, and so we get really cold, and we can get really hot too. And so that thermal cycling on the plastics that were used for wire management, like you can go down there now and it's just the ground's just littered with the white plastic clips that they had used in the beginning. And so anyway, we went through and really hardened the wire management so that they won't have this issue again. But we were able to make the system more efficient, right? Because the modules are rated for 1,000 volts DC. And so we were able to bring up the string voltages and pair them with these Solus inverters, all the while maintaining our interconnection voltage of 480 volts, 3-phase. So I don't know, it was a great experience working with Solus. And like Rich said, this is a company that has these particular inverters have 20 inputs and 10 MPPTs. I think I'm remembering that correctly. It's a large number, whatever it is, and you can go onto their monitoring and you can see, like Rich said, voltage and current on each of the inputs. And yeah, I don't know. And they come with a 10-year warranty. Yeah. I think Solus is a pretty good company for repower work in particular.
How many kW and what did it cost all done?
It was 180K for the repower work. That included everything, equipment, new trenching.
And that's half a megawatt on that, Drew. Drew, another thing too on your system, smaller systems, microinverters and DC optimizers are fine. There is a pretty sizable group of installers and O&M providers that, and I tend to agree with them, that the larger your system, you want to get away from module level electronics, because both the module and the optimizer or microinverter, those are both failure points. All of the connectors are failure points. And you do have a higher probability of issues to respond to, and rooftop fires as well.
Yeah.
So
that's
the
the
larger
theory.
your, well, no, that's the reality. I work with these folks, and so yeah, it's fine for smaller stuff, but once you're getting into, I have seen some half megawatt and full megawatt type systems done with optimizers, and there's a lot of problems. So
how about with microinverters?
I just can't advise that for stuff larger than say a 100 kilowatt rooftop.
Yeah,
but
the problem that I have with that is that when the string inverter stuff fails, the whole thing is done, each one of those inverters. And if the concept is central inverters are a big pain, so we're going to use string inverters, then you can get rid of the string inverter failure problems by going to micros. And
except that, Drew, the string
advantages.
Inverters also allow for, you have more than one input, and so you're not losing an entire one. And so it is a trade-off, but it's not, there's a size limit at which economics of the system start to not work out. So
my guess is that it's really probably up at 5 megawatts and at complete utility scale, as opposed to your 100 kilowatts. That's 5 houses. That's nothing.
Drew,
But anyway.
what's the largest array that you've put the microinverters on? Baker's got a question.
Hey guys, how are you? I guess this is my first time here. So I just want to say something about microinverters and commercial projects, and yeah, I think you're right, Rich. They're not this is cost effective because I did 3 projects, and it was because the customer wanted to. For example, in the case of Enphase, there's something that the actual manufacturer limits you, says like, hey, the voltage rise should not be above 2%, otherwise, you're gonna have these power losses due to the voltage rise, and that's what's gonna happen. Is like in large scales or even in commercial, you have to deal with long
That
distances.
can all be adjusted in the field.
So,
Yes, it can be adjusted by or either increasing your wire size, or it depends if the utility wants to increase the or drop the voltage on the transformer, but now you're relying on somebody else, and if the utility doesn't want to adjust any power or any voltages on your
Well,
side,
they
then
have to keep within their limits, which they often don't, especially when there's a multi-megawatt array pumping up the voltage, which then
yes.
affects nearby residential sites to be out of spec at 250, 60 volts. It's really a problem from that standpoint. But Enphase went through a deal with that where they, from the factory, readjusted the input parameters to comply with the now out of limit utility parameters.
Yeah, you can also do those right through parameters, but like you said, it has to be. It's an extra cost, extra dealing with that, and if you have to do an RMA, that also has to be also uploaded the new firmware on that micro. I mean, it's my point of view. It doesn't mean that it's not feasible, because I've done like 3 projects and they're successfully working. But on the point of view of how much you're gonna save, how you trying to save some bucks on this big project, like my experience is like, and now with the new introductions of the UL requirements, that we can avoid as much as possible all these module level electronics on the roof. Like, for my perspective, it's string inverters is still for me like the best options that I choose when it comes for commercial.
Drew, what is the largest system you have built with
I'm not going to speak for myself. All I can do is refer you to Enphase.
Yes.
I recall approximately 10 years ago, they were marketing the microinverters in the 1 megawatt to 5 megawatt scale. So they have done many large systems out there.
Well, I think they've marketed. I know SolarEdge has been marketing these larger systems, and I've been involved in 2 of them, and they have not worked well at all. So there's what they market for versus.
That's optimizers as opposed to inverters. They still have the string inverter problem at SolarEdge.
That's true.
And the point would be, if you're going to put electronics under the panel or near the panel, put all the electronics there so that you can avoid all of the other DC related problems.
Yeah. So one other thing I'll say, again, you don't have me sold, and that's fine. But I do a lot of characterization, and I want strings so I can hook up my IV curve tracer and literally know what's the degradation of the modules that I'm inspecting. And it's really difficult once you have module level electronics to get that kind of data. Now, I'm a researcher, so I'm coming in from a different perspective, but that's, to me, a big advantage of IV curve of string inverters, is to be able to do IV curve tracing.
But that's for the string as a whole. And
Correctly.
the issue here is you already have the bi-module information in the microinverter, whether a modules or inverters working or not.
So Drew, I'll give you an example. There's an array about 2 hours south of me, 1.2 megawatts, 4,000 modules. I was able to look at the string inverter data, just voltage across all the strings at the site. And I noticed one anomaly out of 4,000 modules. I walked the string of 18 modules and found a junction box with a thermal issue. And that was before I even hit the site. So
that's 200, 200 inverters.
No, it's less. So it's 18 modules per string and then like 15 strings per inverter. I was still able to detect, hey, here's a problem, one module out of 4,000 with string inverters. So it's just a different way to look at the data than
and that's a day's work.
Nope. Literally, it took me a little bit of time in Excel, and then when I'm down there on site, I knew exactly from their layout map where to go walk to.
That's a good thing, as they say, but that's on multi-megawatt. We're sort of arguing about the difference between a 10 kW residential systems where the micros work out great and a limit of 100 kW for a commercial system where they still might work out great, versus my suggestion that they probably work out great up into the megawatt range.
So other issues that people come across, how do your customers feel about cost on whether it's a residential, a commercial, or getting up into community solar gardens and utility scale?
I mean, I can speak on my behalf again. Like on residential, it's gonna be competitive for next year. We know why. On the commercial, I mean, the one thing for commercial is you want to look for reliability, right? You don't want to be going there every time to troubleshoot something. And also, I mean, they have more benefits to you know, like get some credit from the system installed on a commercial side. No, even if the tax credit it's depleted, or they can also use the advanced depreciation mode for that asset, which you can do on the residential. So I believe on the residential it has more impact on the cost saving than on a commercial.
One of the things I've often wondered about on the residential scale is the effort made by salespeople and installers to downsize the system using old consumption data. People's electrical use is going to increase, and making the system smaller than the available area. It just seems to me nuts that you're being, you know, penny wise, pound foolish. Fill the roofs. We're going to need it.
A lot of times, though, it's the utility won't allow you to oversize beyond consumption.
I'd like to know what business a utility has in saying how many panels I could put on my roof. None.
I totally agree.
That's
Here in Colorado,
it's another one of the foot dragging things that they've been doing for years. In Florida, it's having to have $1 million insurance policy if you go over 10 kW. What a bunch of nonsense.
Yeah,
I'm in Florida, and every system that I design, I actually put a 22 kW system on a roof, and FPL came out because I didn't get permission first. They came out and had me remove 9 panels until the guys started using more electricity. But the reason what they will allow you to do is they take a historical value of a year's the previous year's bill, and they will allow you to put 115% AC on there. They don't regulate it. That's only if you want to get net metering. You say they can't tell you what you can put on your roof, but if you want a net meter, that's when they tell you.
Yep.
They say they'll allow you 15% over the AC production of the previous year, and that's what you can install. And that's what they'll approve for net metering. And if you go over that, if you go a little over that, they don't care. But if you go, you just can't. They just don't want to be, even though they're only paying you 3 or 4 cents a kilowatt. They don't want to pay that.
We've only got a few more minutes, but I wanted to throw out one other question, and that is, how common is it to run into issues where you can no longer get spare parts for the system, whether it's modules, the inverter, or other balance of system components that you might need to repair a system?
I'm having trouble with a Canadian Solar 220 panel, getting anything for that.
Another reason to use optimizers.
And in those cases, yeah, if you can get something that fits in place, it's nice to have an optimizer or microinverters, because then you don't need, other than aesthetically, you don't need the same type of module. So that's something that's very convenient there.
I have one quick question
Yes,
before we
Bernard.
go. So I've been an electrical engineer for a lot of years. I've only been doing solar recently, in New York City. So I'm all into the National Electric Code. And then, the code recently has come up with different standards and requirements for doing maintenance. Are there such things as, we've been talking about, we're talking about infrareding and doing other things like that. Is there like a guideline of solar photovoltaic maintenance, guidelines out there, or some sort of recommended practices?
I would have to look. I think there might be one through IEC, or which is International Electrotechnical Commission. Technical Committee 82 is all things solar. You could look there. And then I think also the International Energy Agency PV Power Systems, which is IEA PVPS, Task 12 and Task 13 probably covers that. There's some good documents that have been redone after about 7 or 8 years that share techniques like thermography, which is a great way to quickly find issues at a site, and other techniques too. So go looking. I'd first go look at the IEA PVPS website. And in fact, I think when I'll post onto the community forum for ACES just some links, because I know I have some of those reports.
Thank you.
And then also there is an upcoming IEC publicly available specification called 63525. Its focus is actually on how to characterize and sort modules for reuse after you decommission an array. And that does go through all those different methods. I know this because I'm one of the 3 co-authors on that. So there's some good information there too.
Thank you so much.
And then Nick just told us IEC 62446 is a commissioning and O&M. So let's go with that one first, and look at that and see what it shares for methods.
Thank you so much.
Great. Lively discussion. Thanks, everybody. We're getting out of time. Ella's going to stop the recording here in a moment.